Welcome children, welcome back to my math class. In this video, we will see some more MCQs from 10th standard Cbse chapter 1 real numbers. 15 questions we are seeing from part 1 video. Now this is part 2 video starting from 16th. Now the 16th question is express 98 as a product of its primes. Product of its prime. So we have to see the prime factorization of 98. 98 is the number. So 2 4s are 8. Then 1, 2 goes on 18, 9 times. Then 7, 7. So 98 we can write as the product of primes. That is 2 into 7 square. 7 into 7, 7 square. So the option is option C. Now the next question, 17th question. 3 farmers have 490 kg, 588 kg and 882 kg of wheat respectively. Find the maximum capacity of a bag so that the wheat can be packed in exact number of bags. Packed in exact number of bags. Now here, find the maximum capacity. We have to find out the maximum capacity. So here we have to find out the HCF. Maximum capacity means we have to find out the HCF of these numbers. 490 kg, 588 kg and 882 kg. Right? So we'll find the HCF. 490, 588, 882, then 2, it is divisible by 2. All numbers are even numbers, so it is divisible by 2. Then 2 goes on for 2 times, 2 goes on 9 4 times. Then 1 carrying, 2 goes on 10 5 times, 5 times. Then it is 210, 2 goes on 5 2 times. Then 9, then again, then that is 8, that is 4, 882, 441, again 245, 294 and 441. It is divisible by 7. It is divisible by 7. So 7 goes on 245, 35 times. Then 7 goes on 294, 42 times. 7 goes on 441, 63 times. Now again 35, 42 and 63 is divisible by 7. One more time we have to write 7. 7 5s are 35, 7 6s are 42 and 7 9s are 63. Now we cannot see any common number. That is this common factor we cannot see from this 5, 6 and 9. No common factor among this. So HCF is equal to 2 into 7 into 7, that is equal to 98. 98. Then the option is the first one, A. Option A. Now the next question is 18th question. For some integer p, every even integer is of the form. For options are the 2p plus 1, 2p, p plus 1 and p. Now here also we can use the Euclid's division lemma. Euclid's division lemma says that for every integer a and b, there exists unique integer q and r such that a is equal to bq plus r, where 0 less than or equal to r less than b. This is the Euclid's division lemma. But here we can see that for some integer p, so instead of q we can take p. That means for every integer a and b, there exist unique integers q and r. We are saying q and r. Instead of q and r, p and r. So the Euclid's division lemma becomes BP plus R, where 0 less than or equal to R less than B. But here for some integer p, every even integer is of the form 2p plus 1 and 2p p plus 1p. Now here we can substitute b as 2. B we can give as 2. Now we will see what will happen. Here values of r. R is equal to 0 and 1. Two values are the 0 and 1. 0 condition is 0 is less than or equal to r less than b. So values of r 0 and 1. Two values are there. So when r is equal to 0, we can say that when r is equal to 0, when r is equal to 0, a is equal to, what is b? B is equal to 2 and p, same p, plus 0, that is equal to 2p. When r is equal to 1, a is equal to 2p plus 1, that is 2p plus 1, right? So 0, all of you know that 0 is an even integer. 0, 2, 4, 6, 8, 10 and so on. Even integer. R is equal to 1, 1, 3, 5, 7 and so on. We can say that odd integer. So when we are substituting 0, the value is 2p. When we are substituting 1, the value is 2p plus 1. So even integer is, we can say that 2p, and odd integer is always of the form 2p plus 1. Odd integer is of the form 2p plus 1, even integer is of the form 2p. Or you can directly substitute there also. You can substitute there also when p is equal to 0. When p is equal to 0, it is 2 plus 2. That is 2 into 0 is 0. 0 plus 1 is 1. That is odd. When p is equal to 0, 2p will become 2 into 0 is 0. When p is equal to 1, 2p will become 2 into 1 is 2. When p is equal to 2, 2p is equal to 2 2s are 4. Like this you can substitute and see. Then also the answer is B, that is 2p. Every even integer is of the form 2p. Now the next question is, for some integer p, every odd integer is of the form odd integer. Now I have explained you, every odd integer is of the form 2p plus 1. We can use the Euclid's division lemma. Then we'll get when r is equal to 1, odd integer is of the form 2p plus 1. When r is equal to 3, it is 2p plus 3. When r is equal to 5, it is 2p plus 5. So every odd integer is of the form 2p plus 1. Now the next one, 20th question. M square minus 1 is divisible by 8 if m is an even integer, an odd integer, a natural number, a whole number. 4 options are there. An even integer, an odd integer, a natural number, a whole number. M square minus 1. If it is an even integer, what will happen? First option is even integer. When it is an even integer, m becomes 0, 2, 4, 6, 8 and so on. When m is an odd integer, it will be odd. Odd numbers are 1, 3, 5, 7 and so on. A natural number is starting from 1. So 1, 2, 3, 4, 5, 6 and so on. Whole numbers are starting from 0. So first we'll check even integer. Even integer, first you can give a even number, that is a 0. 0 square minus 1 is equal to minus 1. Then after that a 2 square minus 1 is equal to 4 minus 1 is equal to 3. Not divisible by 8. Now next one is even integer is 4. 4 square minus 1 is 16 minus 1 is equal to 15. Not divisible by 8. So this is not the answer. Now next we'll check the odd integer. Odd integers are 1. We'll give 1 first, right? M is equal to, when M is equal to 1, 1 square minus 1 is equal to, you can say it is 0, right? 1 square is 1, 1 minus 1 is equal to 0. Then next one, odd, next odd number is 3. So 3 square minus 1 is equal to 9, 9 minus 1 is equal to 8. 8 is divisible by 8, right? Now, next one, 5. After 1, 3. The next one, after 3, it is 5. 5 square minus 1 is equal to 25. Minus 1 is equal to 24. So, 0, 8, 24, and so on. All are in the table of 8, right? It is in the table of 8. So, we can say that an odd integer. An odd integer. You can substitute a natural number also. Natural number means you can substitute 1, 2, 3 and so on. Then also you will not get the answer. Whole number also. So the correct answer is B. Now the next question is 21st question. If two positive integers a and b can be expressed as a is equal to xy cube and b is equal to x raised to the power 4. Not xi children, it is x raised to the power 4. X raised to the power 4 y square, x raised to the power 4 y square and z. Here xy cube, it is xy cube. A is equal to xy cube and b is equal to x raised to the power 4 y square into z, xy being prime numbers. The LCM of a, b is, 4 options are the xy square, x raised to the power 4 y square z, x raised to the power 4 y cube, x raised to the power y cube z, right? Now here a is equal to x y cube and b is equal to x raised to the power 4 y square into z. X raised to the power 4 y square into z. Now we have to find out the least common multiple. Least common multiple. LCM. So LCM of first LCM of a and b. We have to find out LCM of a and b. Least common multiple of a and b. So x, we can take LCM of x and x raised to the power 4 is equal to highest one, x raised to the power 4. Least common multiple of x and x raised to the power 4 is x raised to the power 4. And y cube, here next one y cube and this one y cube and y square. We can take y cube. It is y cube, least common multiple, y cube. Then next one here in A we are not given any z, but one z is there in B. So z also we have to take. So LCM of A and B is x raised to the power 4 y cube into z, least common multiple of A and B. So the option B. This is the answer, right? Now the next one is 22nd question. 22nd question is the product of a non-zero rational and an irrational number is, 4 options are the always rational, rational or irrational, always irrational, 0. Now this one also I have explained in my first video, part 1 video. There are 2 cases. What are the product when the rational number becomes 0 and when a rational number is a non-zero number. Rational number is a non-zero number. 2 cases I have proved there. If you can watch it again, you can see that. Then here non-zero rational number. In that question, non-zero was not given. It was the product of a rational and an irrational number. Here it is non-zero rational number. So non-zero rational number example. Now if you want the example, we can take the example. That is a non-zero rational number. We can take it as 3. 3 is a non-zero rational number. Product. Product means it's multiplying with and in an irrational number and an irrational number. Root 3 is an irrational number. So 3 is multiplied with root 3, that is equal to 3 root 3. 3 root 3. 3 root 3 is an irrational number. Is an irrational number. Any number you can take. What is that again? You can take 12. 12 is a rational number, right? 12 into again one irrational number. You can take the irrational number as 1 root 5. So 12 into root 5 is 12 root 5. 12 root 5. That is again an irrational number. An irrational number. So it is always irrational. Always irrational. Now the next one, 23rd question is if two positive integers a and b can be expressed as a is equal to xy cube. This one again I am writing the same question what I have given in this. There it was LCM. There the question was find the LCM. Here the question is find the HCF of A and B, highest common factor. There it was least common multiple. Here x y cube and b is equal to x raised to the power 4 y square into z. So A is equal to x y cube and b is equal to x raised to the power 4 y square into z. So here HCF, highest common factor of A and B. Highest common factor of A and B. Here x raised to the power 4. So highest common factor is x. Y cube, y square. So highest common factor is y square. Here nothing is the xy cube only. Here is it given. So no common factor. Highest common factor we cannot take. So xy square is the highest common factor. Xy square. So option A. Option A. Xy square is the highest common factor of A and B. Now the 24th question is the largest number which divides 60 and 75, leaving remainders 8, 10 respectively is. This one also we have seen once in the part 1 video. Again I'll explain. One more question we are getting. The largest number which divides 60 and 75. So largest number you have to find out the HCF, highest common factor. The largest number which divides 60 and 75, leaving remainders 8 and 10. When 60 divides, leaving remainder 8, right? When 75 is dividing, leaving remainder 10. So 60 minus 8 is equal to 52. When it divides with 60, it is 8. Remainder is 8. When 75 comes, remainder is 10. So 60 minus 8, we have to subtract this. Reminders, we have to subtract from this number. 60 minus 8 is equal to 52. And 75 minus 10 is equal to 65. Two numbers are getting. Now we have to find out the largest number. Largest number means always HCF. Highest common factor of 52, 65. That is equal to, so 52 and 65. You can see the 13. 13 is a common divisor, right? 52, 65. 13 will be the common divisor. 13 4s are 52. 13 5s are 65. So HCF of 52, 65 is equal to only the common, highest common factor. This is actually 13. So 13 is the answer. So which one? Option D. Highest common factor is 13. Now the next question is 25th question. The least number that is divisible by all the numbers from 1 to 5 is. Four options are the 5, 60, 20 and 100. The least number means we have to find out the LCM. Least common multiple, least number. We have to find out the LCM. LCM of LCM of, that's divisible by all numbers from 1 to 5. LCM of 1, 2, 3, 4 and 5. LCM of 1, 2, 3, 4 and 5. That is 2, 3, 4 and 5. Right? No need to take that 1. So 2, 3, 4, 5. First one 2 and 4. We are getting 2 and 4. Both are divisible by 2. So first we will divide with 2. 1 time, 3 time, then 3, then it is 2 goes on 4, 2 times and 5. Right? Now 1, 3, 2, 5. No common divisor. 3, 2, 5. So LCM, not HCF. LCM, least common multiple, least number. So LCM is equal to 2 into 3 into 2 into 5. 2 into, this 2 into 3 into 2 into 5. The answer is 2 3s are 6, 6 10s are 60. So LCM is 60.